to Ka or Kb. Ka just means it's an acid. Little gangster A means acid. Kb means the base. Well, what do you see on the right-hand side? I see H3O+, which means it's an acid. So then automatically, I get a Ka. And then how do I know? Because H3O+ is a product, right? So then if I look here, this has OH on the end of it. OH is a base, right? So automatically, I know it's a Kb right there. And then the reason why is OH minus is a product. So that's that one. So Ka, Kb just stands, and we're going to go through some of the problems you'll see. Questions on that? How do I know it? Because whenever you produce OH minus on the right side, it's a base. Whenever you produce H3O plus on the right, it's an acid. Then they can't give it to you. It just doesn't exist. So you just look at whatever the product is on the right-hand side. So if you have OH minus on the right-hand side, Kb, H3O plus on the right-hand side, it means it's an acid. Equilibrium constant, so A means acid, B means base. Got it? Okay, next. Where'd my little thing go? Right here, back house. Okay, this goes back to pH land. Whenever they give you a table like this, remember this pH land, it's just simple calculations. They're giving you a value. What you have to pay attention to is you have to pay attention to the amount of H's or OH's. So like if I look right here, when I go to start this one, see how it has an H in there, which means it's an acid, which means automatically H and hydronium are the same thing. So this is the same as that, so I'm going to write 1.0 times 10 to the negative fourth goes there. Now they want hydroxide. If I go back to pH land, think about it like this. If I start out with this, 1.0 times 10 to the negative 14th, but that's not what it is. 1.0 times 10 to the negative fourth. If that's 1.0 times 10 to the negative fourth, that times that is always equal to 1.0 times 10 to the negative 14. So all I have to do is do that. I just take it and drop it down below, and I'll get the answer. So H3O plus times OH minus is always equal to, so whenever you go across the top, you're just dividing. Whatever number they give you, whatever number, dang it, whatever, that didn't work, whatever number, take it, that, after I promise. So like if you look right there, I would just do this, 1.0 times 10 to the negative fourth. Now, if I go back to the one we were doing, which is that one right there, that means my hydroxide ion concentration is 1.0 times 10 to the negative 10. When I divide that, that's what you get on the calculator. pH, when you go back to pH line, you should have this written on your test before you even start. I have 1.0 times 10 to the negative fourth. How do I get pH? All I do is take the negative log of it. I'm taking the negative log. That has two sigma figs. That means decimal places. It has to have two decimal places. Everyone should have their calculator out. Take out your calculator. Take the negative log of 1.0 times 10 to the negative 14. You're going to get 4.00. That's where the pH comes from. So the pH is going to be 4.00 because if you look right here, my pH is 4.00. And I go back to pH line. Now, on the bottom, this plus this is equal to 14. So all I do is I just do 14 minus 4.00. That means that's going to be 10. So then if I go back here, my answer for this is going to be 10.00. Remember, sig figs. Oh, that had one sig fig. I messed up the sig figs. And it's in an acid or a base. With a pH of 4, it means it's an acid. Look at the next one. What do I have to be aware of? Because they're going to put it on the test. See the double OHs there? You got to pay attention. If there's OHs, you look for parentheses. If you see parentheses, that means the first thing you're doing is you're just multiplying times 2. That's all you're going to do. Yeah. Always. Because if you go back to pH land, here's the way it works with pH land. You decide, this tells you if it's between less than 7, it's an acid. If it's above 7, it is a base. The only way you can tell is you have to get over here. That's the only way you can tell. So then I go back to the original question that I was talking about here. I'm going to take 3.6 times 10 to the negative third. That's OH. It's the same thing as hydroxide. So when I double that, what do I get? 7.2 times 10 to the negative second? No. So what comes out to me? What do I get? Negative third. 7.2 times 10 to the negative third. So I get 7.2 times 10 to the negative third. I got to get everything else. Well, think about pH line. Here's where they're starting me. They're starting me right here. 7.2 times, ay caramba, no they're not. 7.2 times 10 to the negative third right there. That means I just got to get the other 3. So the first thing I'm going to do is always just take the negative log and go to the bottom. So I take 7.32, E, punch in your calculator, hit log and sign change. What do you get? Because going back to this, what do you see there? The parentheses. Look right there, there's a 2 with the parentheses. You got to pay attention. If there's parentheses, you got to double it or triple it. Okay? So that's where that came from. So if I look right here, I would take this. What do you get when you take the negative log? 2.14 is my pOH. How do I find pH? So I'm going to go 14 minus 2.14. What am I going to get? 11.86. So because this plus this is equal to 14, the last thing I have to do is to go up and get H3O plus. All I do on my calculator is hit 10 to the negative 11.86. Because to go opposite this way is just 10 to the negative pH. So I take my calculator, I go 10. If you have a YX key or a caret, depends on which calculator you have. 11.86 negative. You're going to have to come back, kid. Okay? Oh, your book? Hold on a second. So you're going to get you'll end up with 1.4 times 10 to the negative 12 would be that. Alright, so next. I'm not going to do another one of those because it's too redundant. But if you look at the next one, how many H's do you see right there? I see 2. So the first thing I'm going to do is I'm just going to multiply by 2. Since it's H, it's going to be hydronium. I would start there and pop it into pH line. Look at 11. What's the first thing I notice? It's a pH line problem. There's OH2. So the first thing I'm going to do is just multiply by 2. So I take 0.09. If I multiply by 2, right? So I take 0.09, I multiply by 2. What do I get? It should be 0.18 for OH. Then it asks, what did it ask in that question? What is the pH? So all I'm going to do is negative log, subtract it from 14, and bam, you get the answer on there, which is 13.22255. Now, why does it have 3 decimal places? Look, see how it starts with 3 sig figs right there? After you go to the bottom of pH land, it's decimal places. Next one. What? Next. Look right here. If you see an OH in parentheses, you multiply it by 2. If you see an H with an H on the front with a 2 or a 3, you have to multiply. Just that. Those 2. Now, notice here it says I'm going to start with 13. It says Kb. There's 2 formulas you got to pay attention to. X squared over molarity is equal to Ka, or X squared over molarity is equal to Kb. If this says Ka, it means an acid, and an acid means X is the same thing as H3O plus. Then you go to pH line. It's going to ask you to find pH. If it says a B, it means X. When you find X, X is going to be equal to OH minus. So the first thing you decide, whenever you see a Ka or a Kb, you know you're going to use this formula first, pH land second. That's how you tell the difference. What? Okay, but let me do these. I'm doing problems right now. Let me do these. Okay, so like if you look here, if you look right here, I have molarity here, I have Kb. So watch what I'm going to do. This is my M, it goes on the bottom, I go 0.140 on the bottom. X squared on the top is equal to 1.78 times 10 to the negative 9. Everybody take their calculator, all you have to do is tell me what X is. Multiply these and take the square root when you're done to get rid of it. So we'll multiply that times that and square root it and tell me what X is. Do that right now with your calculator. So I'm going to go 0.140 times 1.78 E negative 9. Take the square root of that sucker. What'd you get? What's x? Okay, 1.5, we'll say 8 times 10 to the negative 5th. Now, because that is a b, when I go to pH line, because that's the second step, well, I'm going to do this. I'm going to go over here, and I have 1.58 times 10 to the negative 5th. The reason I do that is to get the number. Now, she wants pH. So how do I get pH? Well, first thing I got to do is take the negative log. So everybody hit log, sign change. And I get 3 here means 3 decimal places. So I'm going to get 4.802 is my POH. How am I going to get pH? Because on the bottom I just subtract it from 14 to bounce over. So I go 14. I'm going to do 14 minus 4.802, and I get 9.198 okay, I'm off one digit. See, it's 158.5. I'm off one digit when you subtract it, but it's right there.
One square root.
Because if this is x squared, you're trying to find x. The opposite of x squared is square root. You got to simplify it. Yes. This one, pH line. Because if it starts here, it's 3 decimal places. It's 1.58 times 10 negative 5th when I start here. Sig figs, it's 3. Did I do 4 when I did it? Oh, that's right. I don't remember what I did, but I know I only did 3 decimal places. It was 3 decimal places. So if it's 3 sig figs here, it's 3 decimal places there. Now, let's look at the next one. Let me do the next one. Watch. If you look here. Let's see here. We'll do this one, 12 first. 12. It says KB, so I know the formula automatically is going to be mx squared is equal to KB. Now notice she gives me the molarity, so that goes on the bottom. So that's going to be 0.00650 goes on the bottom. This is different because it's asking me for KB. So that means I have to have x somehow. So watch, when this is KB, what does x have to be on the top? Has to be OH minus. So I need OH minus on the top, and I have to square it. Well, she gives me a pH of 10.64. So if I go back to pH land, so in this case, if I have a pH of 10.64, but I need, for the KB, I need an OH, what am I going to do? First thing I'm going to do is subtract it from 14, so I'm going to go 14 minus 10.64. I get 3.36. And I still have the number I need. Then how do I go from here to here? You should have this written on your test. You just go 10 to the negative 3.36. So when I take my calculator, 10, 3.36 negative, I get 2 sig figs. So 4.37. 37 times 10 to the negative 4th. That's what I get there. That's my OH. So when I go back to the problem here, when I go back here, that's what I'm going to drop in here. I get 4, what did I say it was? 4 point what? 37 times 10 to the 4th. So then I can find my KB. Because they're going to give me the X. I find X with pH line. They gave me molarity. And pH, I can convert it to what I need on the top. So what I would do is go 4.37 e to the negative 4th squared divided by 0.00650 equals, and I get, that's a little off, 2.9. I get 2.9 times 10 to the negative 5th. It's close. Could be rounding. What? Yeah, it's a little off because I rounded that right, so it's a little sketchy. Next one, look at this one. Look at the last one. If you look right here, it says, gives me pH and it gives me molarity. Remember the formula, it's asking you for Ka, so x squared over molarity is equal to Ka. Molarity is always going to go on the bottom, so I go 0.0208. If this is Ka, what has to go on the top? H plus, HCl plus. So she gives me pH, so then I just go back to pH land. It's 2.17. So I'm going to go back to pH land. This is 2.17. I need H3O plus. How do I get that mathematically? I just go 10 to the negative 2.17. So when I put that in my calculator, I'm going to go 10, 2.17, negative, and I get, boom, I'm going to get this. So my H3O plus comes out to be, it's going to be, since it's 2 decimal places, 2 sig figs, so it's going to be 6.8 times 10 to the negative third. That's my H3O plus. So if we go back to the problem, we go back here. So I just said it was 6.8 times 10 to the negative third. So I go 6.8 times 10 to the negative third. But remember, it's not x in that formula. It's just x squared. So I square that sucker, boom, divided by 0.0208, boom shakalaka, and I get 2.2 times 10 to the negative third. Boom. So if you see a Ka or a Kb, you know it's a formula. That means it's going to be x squared over molarity, Ka, or x squared over molarity is equal to Kb. This x is going to be OH minus, and this is going to be H3O plus. On some of the problems, she's going to start you with pH. So you just got to change it into x. And if she wants pH, like in this one, see how she asked you what the pH of the solution is? So you're solving for x and then finding pH. It's all, then you go to pH line. Let's look at the next set. Bronzed-Lowry acids and bases. If you look at Bronzed-Lowry acids and bases, you just count the number of H's. See how there's 2 H's there, 1 there, 1 there, and 2 there. Notice you have H2SO3 here, and it's there too. They match. The difference is it's gone down by 1. Anytime it loses an H, it's an acid. See how this has 2 H's? Now it has 1, so that's an acid. That makes that the conjugate base. See how the CO3 has 1 H? Now how many H's does it have? 2. Anytime it goes up, it's a base. So that's a base. That automatically makes that a conjugate acid. Look here. 4 H's. Now it has 3. Did it go up or down? Went down, so that makes that the acid, conjugate base. That has 0, now it has 1. That makes that the base, conjugate acid. Does that make sense? Okay. When we go to do titration curves, easy. This is easy. You're gonna love this piece of cake. It's so easy. Watch this. Put your wine in. Put your wine in right now. Watch. Hold on. Stop the whining for a second. Look. Here's how it works. Watch this. This is how you do this real easily. You find 2.0, you make an arrow. You find 12.0, you make an arrow. Anything above is a strong acid. Anything below is a strong base. Right? So strong acid there, strong acid there, strong base there. Anything in the middle is weak. Now watch. So look, if it's there, what am I starting with? It's below 7. It's a strong acid because it starts below 2. Equivalence is going to be exactly 7. And equivalence is halfway in the vertical. Here, it finishes, where does it finish? About 12. So that curve is a strong acid, strong base titration. I start with a strong acid. I finish with by adding a strong base to it, neutralizing it. Look at the next one. I'll do the next one. Move this one. I draw a line at 2, and I draw a line at 12. Where am I starting? There's my dot right there. It's a weak acid because it's below 7. So that's a weak acid. Where do I finish? Above 12. So that's a weak acid, strong base. Whenever it's a weak acid, it means it's going to be above. Think weak acid WA means it's going to be above 7 at equivalence. Look at the next one. If it's a weak acid, its pH is going to be above 7 at equivalence. Hold on, let me show you this one. Look right here. Same thing, 12 and 2. Look right here. Where am I starting? I'm starting right there. If I'm starting right there, is that a weak base or a strong base? Weak base because it's below 12. What am I adding to it? strong acid. And if it's a weak base, think of WB. At equivalence, the pH is going to be below 7 because it kind of gets shoved down. Weak acid, the pH at equivalence would be above 7. If it's strong and strong, they're the same. Think S and S is the same. Hold on. Now, check out this. Look at this. Starting substance, that's about like 11 something. Is it an acid or a base? It's a base. Why is it a base? Because the pH is above 7. Is it being titrated by an acid or base? Well, where does it finish at? Finishes below 2. So we know it's an acid. Why? Because the pH is lower than 7. What is the equivalence point? Equivalence point is halfway. This is an awful picture. I zoomed in too much. But if you look right there, it's going to be below 7. It's going to be like 5, I think, on that graph, somewhere around there. What is the strength of the acid? Well, is it below 2? Yeah. So it's a strong acid. So it's strong. And the base is below 12. So it is weak.